So we're starting right here under solving by elimination, but they actually show us the graphing. All right. We are now talking about 3 dimensions. So we're talking about 3 different things that can happen here. You have, what you're looking for is where all 3 of them cross. All 3 of them cross. And so you're going to have an X, a Y, and a Z. There's 2 possibilities for a no solution, right? No points lie in all 3 planes, which meaning they can actually intersect each other, but not all 3 of them intersect. Or they can all be parallel, which means you would have no solution as well. So these 2 options are no solution, where 2 of the planes cross, but the 3rd one doesn't cross with the other 2 in the same spot, okay? Then you have where they all cross in exactly 1 point, an X, a Y, and a Z, all right? X, Y, and Z. And then you can see where they all cross in 1 line. And then you have a line as your answer. All right, so 1 solution is what we're typically going to get here. There might be times when you have infinite, and there may be times when you have no solution. And the no solution will look very much the same as it does for a 2 variable. The difference between this is we're adding a 3rd dimension, which we're adding a 3rd variable. So let's look at example 1. So solving by elimination. Conceptually, it is the same. It's just longer, honestly. What we have to do is we have to eliminate the same variable from all 3 equations. And we do that 2 equations at a time. And so what I always do is I look for the easiest variable to eliminate. In this case, either X, Y, or Z really are all easy. But honestly, the easiest one that I would see here would be Y. Because I have a -3 and a +3 and a -3. It's all the same coefficients. In fact, some are already positive and some are already negative. What we're going to do is we're going to take 2 equations at a time. You take 2 equations, it doesn't matter which 2, and then you take 2 different equations. So one will be the same as what you just used, and then the other equation, and we're eliminating them. And so I would personally start with equation 1 and equation 2, and we're going to do the exact same process. We are going to just add them. So I have X minus 3Y plus 3Z equals -4. And I have 2X plus 3Y minus Z equals 15. This is already set up for me to eliminate. And so I'm just going to add these down. 1 and 2, it's going to give me 3X, -3 and +3 will cancel. 3 and -1 will give me 2. And then on the other side, -4 and 15 will give me 11. All right, so I have eliminated Y. Now I'm going to eliminate Y using 2 different equations. So this one was using the first 2 equations, okay? Now I'm going to do the same thing using 2 and 3. It does not have to be in this order. Sometimes you'll find that 1 and 2 and then 1 and 3 work better. Whatever is easiest to do here. All right, so I'm going to take 2 and 3. So I'm going to say 2X plus 3Y minus Z equals 15. And then the bottom one, 4X minus 3Y minus Z equals 19. I'm doing it that way because I don't have to multiply anything to do it, which will not always be the case. All right, so 2 and 4 give me 6X. Again, my Y's cancel, which must happen for this to work. And then -1 and -1 give me -2. And 15 and 19 give me 34. All right, so I've successfully eliminated Y. Now I have something that I've already done. In fact, this is what you did for bell work. I have 2 variable equations. So what am I going to do? I'm going to use those and solve by elimination. So I'm going to take this equation that I have here, 3X plus 2Z equals 11, and I'm going to add it to the other equation, 6X minus 2Z, they were very nice, equals 34. All right, and then I'm going to add those down. So I get 9X equals 45. X equals what? 5. All right, my answer here will be an X, a Y, and a Z. It is a 3-dimensional point, okay? X, Y, Z. So now that I have X, I can go back to either one of my 2 equations and plug it in, all right? Either one of them. So I can just say 3 times 5 plus 2 times Z equals 11. All right, so I get 15 plus 2Z equals 11. Subtract 2Z equals -4. Z equals -2. I now have X and Z. How do you think I get Y? Yeah, I'm going to plug that in. So I'm going to take both of these and plug it into any one of these equations. So I'm going to say x, well, that's 5, minus 3y, plus 3 times negative 2 equals negative 4. All right, 5 minus 6 is negative 1. Add 1, I get negative 3. Y is going to equal 1. So my answer is going to look like this: x, y, and z. Now you can check these, obviously. Plug x, y, and z into your equations and see if you get a true statement. So you would check them exactly the same way you would check any equation where you solve for the variable. So there will be times when you have a variable already missing from one of your equations. That's actually beautiful, right? Because then I have one less thing to do. So I'm automatically going to use the equation that is missing one. I'm automatically going to say, well, I definitely want to use this guy because he only has 2 variables to begin with. And then I'm going to intentionally eliminate that missing variable from the other 2. All right, so if I'm missing y here, then I want to eliminate y from the 1 and 2. Because there's one less thing I have to do. So I want to take this guy here and this guy, and I want to eliminate specifically y, because I already have a 2 variable that is missing y. So it's one less elimination that I have to do. And so I would just eliminate my y here, right? So 6 and 1 give me 7, negative 3 and positive 3 cancels. Positive 3 and negative 1 give me 2, and negative 6 and 10 give me 4. So now I have 2 equations already that are just 2 variable. That is not a negative 4, right? And so I'm one more. So what I find is that giving these problems with missing a variable throws people off, because then all of a sudden they're like, wait, what? And they'll start eliminating the z, and then they have to actually add in a y to the equation because there wasn't one to begin with. So when you're missing a variable, that's the one you want to eliminate from the other two. All right. And so I would just finish this guy out, right? 6x, those 0 out. That gives me 12. And then I'm just going to plug it back in and finish off like I would. All right. Makes sense?